Okay, second example. So the amount of juice in a carton, this is the one from your textbook actually, it's on page 56 if you want slightly better wording, has a normal distribution, standard deviation 3 millilitres. The company claims that the mean, population mean, is 60 millilitres. A trading inspector has had a complaint and believes the company is overestimating the mean and takes a random sample of 16 cartons and finds the mean to be 59.1. So it's looking a bit low, but is it low enough to say that the population mean isn't 60? Because you expect a bit of variance, obviously, variation, I should say, within your means when you take a sample. So we're going to test it at a 5% significance level this time, which is a bit more usual, to be honest. So same start. So the null is that the mean is 60. The alternative, so he thinks or she thinks that the mean of the population might actually be less than 60, or at least that's what they need to test, where mu is the mean amount of, I know it's annoying writing words in maths, gonna have to do it. So define your parameter. We'll check that on the mark scheme though. I know for the binomial ones, if you don't define p, you lose a mark. So I'm imagining it's the same here. So the mean of the samples, so they're normally distributed, and the nice thing is the mean stays the same as it is in the population, and the variance is 3 squared over 16. And so quick sketch, mean is at 60, we're somewhere here at 59.1, and we need to find that probability of being in the tail. So we want the probability that the sample mean is less than 59.1 in this here, this distribution. So, ta-da, menu, no, turn it on, menu 7. Normal CD, we only do CD for the normals, don't worry about the PD. So the lower, I can just pop in 0, upper 59.1. Standard deviation, so remember, just be careful with this. So it's 3 over the square root of 16, which is 4. So 3/4 or 0.75. And the mean is 60. And so this probability here is coming out as 0.115. And then converting that to a percentage, that's 11.5%. So what that means is that in this population, in this distribution where the population mean is 60, if you take a sample of size 16 and you find the mean of it, then you will get a mean of 59.1 or less, 11.5% of the time, which is actually quite likely. It's more than 1 in 10, it's actually quite likely. And that's more likely than the significance level. And so for this one, you accept the null, because you actually have quite a high probability here of getting a mean as low as 59.1. Let's say that the right way around, I think I did. So the probability of being in this tail is quite high. So 11.5%, it's higher, it's more likely than this significance level of 5%. So accept the null. So there is insufficient evidence this is the boring bit, isn't it? to suggest the trading inspector is correct. Or something like that. The only other thing I wanted to say was two-tailed test. So if it read instead, the trading inspector wants to discover whether this is correct or not. So you're not saying, is it an overstatement, is it an understatement? Then you would be in a two-tailed test. So keep an eye for that. I'm going to put one on your questions. That board's really grubby on the back. If it's a two-tailed test, just to remind you, that one's not much better, sorry. So your null would still be that the mean is 60, and then the alternative is that the mean does not equal 60, and then you would then perform the same test, but this is where you really need that sketch, because you need to know which side of the mean you are. So I'm just going to do exactly the same one, but with a two-tailed test. And then you would find probability of being less than 59.1. But rather than compare it with 5%, you half your significance level on each tail. So you would compare this probability with 2.5% instead. So that the wording would be different. It would just be something like a trading inspector would like to test whether this mean appears to be correct. So it's whether or not a value seems right for a two-tailed test. But I'll pop one in your questions at the end, and then you can just have a little go at one of those as well. But exactly the same process. You just half your significance level, because you actually need to check sort of both ways. So you do 2.5% there, 2.5% there, and that gives you an overall significance level of 5% when you add them together. But yeah, you should be right with that from binomial, but any bits that you're not, then do say, no problem.